Subscribe.
Hey y'all, welcome back. So let's jump into tonight's homework. It's all about problems that you can expect to see on the CLEP test. Really taking these linear function ideas that we went over the last 2 units and kind of putting them all together. So a lot of times these questions are going to require multiple steps, and I think this homework will kind of guide you through step by step how you solve some of these. So you'll notice like some of them are just sort of set up problems for a future problem, and you'll see once we kind of get going through it. So let's look at number 1. This graph, the inequality y is greater than or equal to 0. So that's just going to be a horizontal line at y equals 0, which is this line right here. And since it says, caps lock, okay. Since it says y is greater than or equal to 0, then we want to shade in all the points that are above that line. So let's go ahead and do that. Do a nice little shade here. All the points above that line. So basically any point in this shaded region here, or you know what might be easier is if we just make a rectangle. Any point in that shaded region is, sorry, here we go, is going to be a solution to the inequality. So really any point that has a y coordinate greater than or equal to 0 will count, and it'll be this entire region here. Number 2 says graph x is less than or equal to 0. So x equals 0 is going to be this line going along the y-axis here. Okay, this is where x equals 0, but the problem is asking us to graph where x is less than or equal to 0. That's going to be everything to the left of that line. I'm going to shade in this entire left-hand part. Go all the way up to the line, looks good, and there we go. So every point in this region has an x-coordinate that is negative, or 0. Number 3 is going to kind of put all this together and says, the shaded region in the figure represents the intersection of the graphs of y greater than or equal to 0, which is this one up here, x less than or equal to 0, which is this one over here, and which of the following inequalities. So basically what we're looking for is what inequality could be used to come up with this other line with the shading going above. Okay, so we've already established y greater than 0 is going to be all the points that are above this line right here. Let me make that a little darker. And then all of the points to the left of x equals 0. Here's x equals 0. It's going to be on this side. And then finally, there's one more inequality that's going to essentially wall off the shaded region, and our job is to figure out what is this line right here. We can see that we're shading up versus down, so right away we know that it's going to be a greater than or equal to symbol. Okay, so the fact that it's shaded above the line means that we're going to have y is greater than or equal to. All right, so let's look at our answer choices, see if we can't knock out any just based on that fact alone. We could eliminate choice B because that says less than, choice A says less than, but C, D, and E all say greater than or equal to. So we've narrowed it down to 3 choices just by recognizing that one fact. So the next thing to do is to actually come up with the equation of this line, since we already know what the inequality symbol is going to be. So we're just going to use the slope and the y-intercept, and I'll start with the y-intercept, which is right here at -2. So the line that we have should have a y-intercept of -2, and unfortunately we can see that all of these have a y-intercept of -2, so that doesn't really help us, does it? Now we could see, based on the graph of this line here, that it has a negative slope because it's going down and to the right. It's going down as we read lists from left to right. So we know that our slope has to be negative, okay? So that's going to allow us to eliminate choice D because that had a positive slope. That gets us down to C and E. You can do this amount of, sort of process of elimination. Now a random guess is going to be 50% chance to be accurate versus 20%. It really improves your odds as you take away those possible answer choices. But Really, the only difference between these two is the slope. Is it negative 2/3 or negative 3/1? So what I want to do is take a closer look at this line. I can see that I've got a coordinate right here, not labeled, but it's negative 1 comma 1. And I have another point, this y-intercept, again, not labeled explicitly, but pretty obvious what it's supposed to be. Can I plot this? I'm trying to make a little circle here. Let's do one of these. Got these 2 points. And to get from one point to the next point, I'm going to check my rise over run. I'm going to go down 1, 2, 3, run 1. That means our slope is negative 3. And so our answer here is going to be, oh, nope. Like I'm trying to block it out. But yeah, it is going to be E. It's got the correct slope, correct y-intercept, and it's being shaded above. So that's number 3. Number 4 says the shaded region in the figure represents the intersection of y is greater than or equal to x, y is greater than or equal to 1, and which of the following inequalities? So this is another, basically the same problem, but just different lines. The first one, y is greater than or equal to x. So it says that one's already graphed. Let's see if we can't identify what that's talking about. Now, y equals x is your parent linear function. It's got a y-intercept of 0 and a slope of 1. We can see right here, up 1 over 1, up 1 over 1. So this line right here is the y equals x. Okay. And since it says y is greater than or equal to x, you can see that, yes, in fact, we are shading above that line. It's also saying that y has got to be greater than or equal to 1, which would, if we had y equals 1, that would be this horizontal line here. Here, this is the y is equal to 1 line. And then it's at the actual inequality says y is greater than or equal to 1. So that means that we would shade up. We would shade above that line. And we can see that reflected here. You know what? There's a little piece of missing information here, I think. How do we know this is shading to the right? That would be x greater than 0. So yeah, I need to remember to throw that back in here. X greater than or equal to 0. Okay, so the last, that one's not even on there, but you can see it is shaded to the right of this y-axis. So that's a piece of missing information here. I did not realize till I worked it right now. So I'll make sure to make that correction before I give this problem to you, so that you can have the fixed version. Okay, but anyway, it says, which of these inequalities is going to be reflected on this line? Now, right away, we can see that this is shaded downward. Okay, so that means that it should be less than or equal to. So that's going to eliminate all these greater than or equal to options. That leaves us with just these two. We can see that the y-intercept of this line is positive 3. It's got a slope of up 2 over 1. So the only possible answer choice here would be choice A. Y less than or equal to 2x plus 3. That's assuming I include this other little inequality in there to really make this actually solvable. Yeah, there we go. So yeah, 4 should be A. Number 5 says rewrite this equation ax plus by equals 1 in slope-intercept form. Okay, so let's go ahead and do that. I'll start with just the regular old equation. And then I'm going to subtract ax from both sides. So negative ax plus 1. And then finally, I'll divide both sides by b and get negative a over b, x plus 1 over b. All right, that might come in handy later. So, but that's really all there is to that particular problem. 6 says write the equation ax minus by equals negative 1 in slope-intercept form. So here we're going to be doing pretty much the same thing. Start with ax minus by equals negative 1. We're going to subtract ax from both sides. That's going to give me negative by equals negative ax minus 2. Subtracting the ax from both sides. Move this over to the right. And then finally, we're going to divide everything by b, or not by b, but by negative b. That's going to give me positive a over b, because a negative divided by negative is positive. X, and then minus, or no, actually plus for the same reason, right? Negative 2 divided by negative b should be positive, 2 over b. Okay, so number 7 says the figure shows the graph in the line, shows the graph of the line with the equation ax minus by equals negative 1. Notice that's what we have over here in number 6. Okay, so we're just kind of guiding you through this. Which of the following must be true? And then there's some answer choices that deal with the whether or not b or a is positive or negative for the most part. So right here, notice that we've got a negative slope, okay, and a positive, can I spell positive y-intercept? Negative slope, positive y-intercept. Okay, now my slope here is going to be a over b. Okay, so that means that a over b has got to be negative slope. And it says 2 over b has to be positive. That's the y-intercept. It's up here, this 2 over b. Grab this equation here so I can scroll down a bit. All right, we already solved this for y. We did that in question number 6. And so from here, we can see that, well, if this number right here needs to be positive, then that means that b must be positive. If b was negative, then this whole number would be negative. We'd be dividing by a negative, and therefore we'd have a negative y-intercept. Now, if you could just kind of reason your way through that, that's great. If you struggle with that reasoning to get to the point that b has to be positive, then what you could do, although this is probably more work than it's really worth, just to set b, or 2 over b has got to be positive, so it's got to be greater than 0, then multiply. I guess that won't really work. Multiply both sides by b. So yeah, forget that. How would you do it that way? Well, you get 2 greater than 0. I guess it's going to be true. Yeah. Okay. So anyway, b's got to be positive. This thing's got to be positive, then that means b has to be, because 2 is positive. Okay. So if b is positive, we know this b is positive now. Then we will need, if we need this whole slope to be negative, okay, and b is positive, the only way to get a negative out of this is if a were negative. Okay, so a is less than 0, b is greater than 0. And so now we just want to find the answer choice that reflects that. A less than 0, b greater than 0. Oh, it's just choice A there. How about that? Yeah, I don't think the rest of these are going to work. Yeah, there you go. 7. Number 8 and 9 are graphing problems. We're going to graph these inequalities, but before we really get into the graphing, let's solve for y so we get it in slope-intercept form. And I'll do that by first subtracting 4x from both sides. Then I'll divide both sides by negative 2, but be very careful here. We're dividing by a negative, so you do have to flip that inequality symbol. So 4 divided by 2 is 2. Then 12 divided by 2 would be 6, so minus 6. So this is the equation in slope-intercept form. It'll be a little bit easier to graph this probably, although you could get away with just doing intercepts here. I just have a habit of converting everything to slope-intercept form. So we've got a point at 0, negative 6. That's the y-intercept. Slope is 2. I'm going to go up 2 over 1. Up 2 over 1. Just continue this pattern. We get enough points to really get a good idea of where it's going to go for the rest of the grid. Probably good enough. Going to go up 2 over 1, up 2 over 1, and so on. Right, just trying to get a straight line here. Let's see if we can't. There we go, that's pretty good. Okay, now, hold up here. It does say y is less than, not y is less than or equal to. So, redraw that line, unfortunately, because it needs to be dotted. Okay, so let's go up to, what was I? Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Well, I thought I changed it to dotted. Third time's a charm here, right? Yep, it would be if I could draw a straight line. Here we go. Geez, that took way more effort than I thought it would. But yeah, we should have a dotted line here. It says y is less than 2x minus 6. So the shading is going to be below the line. I'm going to shade all this. But I think it's still stuck on dotted line. It kind of looks kind of weird there. All right, so yeah, we want to shade all this. So every point in the shaded region is a solution. Now this does have a follow-up question. Which quadrants contain solutions to that inequality? All right, so solutions are going to be any points that are in the shaded region. And we can see that we've got points in quadrant 1, not quadrant 2. Okay, so remember this is quadrant 1, quadrant 2, quadrant 3 in the bottom left, and then quadrant 4 is in the bottom right. So we do have some points in quadrant 1, none in quadrant 2, a little bit in quadrant 3, although it would be more if we left this grid go a little lower. And then obviously quadrant 4 has some points. So, so the quadrants that contain solutions would be quadrants 1, 3, and 4. All right, now on this next one, we're going to do kind of the same thing. You're going to go ahead and put this into slope-intercept form by subtracting 5x from both sides. And actually, that'll be it. Y does not have coefficient, so we don't have to divide by anything. There we go. This is the equation in slope-intercept form. Doesn't explicitly ask you to do that, but I just think it makes the graphing a little easier, especially since your x-intercept here is going to be a fraction. So yeah, my y-intercept here is going to be at 6. And the slope is -5, so I'm going to go down 5 over 1, down 5, 1, 2, 3, 4, 5 over 1, 5 over 1, and that's really all we can fit here, right? I don't even think we can fit another one up here. So let's go ahead and graph our line here. That is not a line, that is a circle. Gosh, I swear, sometimes I hit the button and then it just doesn't what I want it to do. Which is life. All right, here we go. There's your line. And, ooh, it should actually be a dotted line, like the last one, because it's strictly less than dotted line. Pretty close. Okay, and then the shaded region here is going to be below because it's y is less than. Draw a little shade going down the bottom half. All right, so we want to shade all of this. Try to get as close as I can to that line, covering it. That's pretty good. And we are done. Okay, so that's the graph of this linear inequality. It says which quadrants contain solutions. So see on here, they all do, right? 1, 2, 3, and 4. So we'll just say all of them. Now there's no quadrant being left out. It almost looks like one got left out, but you can see there's still a little shade going on in there. Okay, all 4 quadrants. What happened to my shade? Disappeared. Okay. Did I not? Am I going crazy? Did I not shade already? Must have hit something. So just trying to get the shading back on here. I swore I did it, but I've done so many of these that maybe I just didn't do it. All right, but yeah, at any rate, all 4 quadrants should be your answer. All right, number 10 says Craig buys a house for $120,000. At the same time, in a different town, Katrina buys a house for $80,000. $80,000. I don't know where you're buying a house for that much these days. The value of Craig's house decreases by $500 per year, while the value of Katrina's house increases by $250 per year. Or A says, write an equation to represent the value of Craig's house in terms of the number of years since it was purchased. So I'm going to use V for value, but you could use really anything. And I'll use T to represent time. So V of T, or sometimes you'll just see it V, equals Craig's house started at $120,000, and then, if I'm reading this right, decreases by $500 per year. We'll make sure that T is in terms of years. Part B says, write an equation that represents the value of Katrina's house. Same idea here, but hers is going to start at $80,000 and increase by $250 per year. This one's just asking you to set up the equations. You don't actually have to solve it, so that's kind of nice. Yeah, that's it for number 10. Quick one. Number 11 says Amy opens a bank account with $5,000 and makes no additional deposits or withdrawals. During the same week, her friend David spends $15,000 on a new car. At the end of each year, $250 is added to Jana's account, while the value of Emily's cars decrease. Emily. Typo. Who's got the car? David. Gosh, don't you guys love how I definitely proofread these before making these videos? Should be David's. While the account of the value of David's car decreases by $500 per year. Okay, so let's first write an equation to represent the value. So I'll use V again, like the last one, the value of Amy's bank account in terms of the number of years. So we'll just do T again. So V of T equals the initial amount, $5,000, and then, yeah, hold on. I read this so fast, I didn't even catch this other one. This is supposed to be Amy. Jeez, Mr. Schuler, come on. Who wrote this problem anyway? Yeah, I can imagine you'd be quite confused with this problem if you don't. All right, anyway. So, yeah, let's go back to Amy. $5,000 initially. Since $250 is being added to Amy's account every year, we're going to say plus $250. Part B says write an equation to represent the value of David's car. Same idea here, except you might imagine our initial amount is going to be different. It's going to be $15,000, and the value should be decreasing here by $500 per year. So here are 2 equations. Sorry about the typos on this one. Make sure to get that fixed in the future. Number 12. Which of the following is an equation of the line that passes through the points 2, 1, and -1, 2? All right, this is our last question. So there's 2 ways we could do this. One is just to find the equation of this line and put it into standard form, see what's our answer here. Or we could just test points, like test 2, 1, and see which of these equations works with that point. So let me show you the first method. First thing we would have to do is find the slope here. So my change in y from 1 to 2 is going to be +1. My slope is going to be +1 over, and then from 2 to -1 is going to be -3. So that's going to net us -1/3. Slope. And then we don't know the y-intercept, so we'll put it in point-slope form. That's going to be the y minus y1 equation. The y minus 1, I'm just going to use that first point, equals the slope, which is -1/3, times x minus 2. So here I would distribute that negative 1/3. Give me negative 1/3 x minus, or actually plus 2/3. Okay, and then if I add 1 to both sides, 2/3 plus 1 would be the same thing as 2/3 plus 3/3. That'd be 5/3. All right, so to get this into, we got it in, we start with point slope form. We got it to slope intercept form, but now we can put it in standard form. So I'm going to add 1/3 x to both sides, and then multiply everything by 3 to get our equation. I missed something here? I feel like I missed something. Plus, oh, I see. Yeah, this should be 5/3, and so when I multiply that by 3, that just gives me 5. I was thinking, see 15 anywhere. But that's how I knew something was up. All right, so here we go. Our the correct answer here is going to be this one right here. If I can box it without filling it in, that'd be great. Right here. So our answer choice is going to be B. But I did say there's another way you could do this, and that is you could just test these points and see if they work. So like if I test 2, 1, for instance, I would get 2 plus 3 times 1. And the question would be, like, does that equal 5? And it should, since we already know it's going to be the right answer, but let's test it. That does equal 5, okay? 2 plus 3 does equal 5. And then if we test the other coordinate, negative 1, 2, we get negative 1 plus 3 times 2, which also equals 5. So both points work. If you were to do it this way, you would want to make sure to test all the other equations, just to make sure you don't make a mistake. I just knew that this was going to be the right answer because we worked it out over here. Oh, let me scroll up a little bit. I just realized my face is in the way, so let me hide myself here. Or I guess I can move myself over here. There we go. Yeah, you basically just want to test these points out on each equation if you get lost in this algebra. So you can actually answer this just sort of like by going answer choice by answer choice and testing the points. But if you know what you're doing, it's going to be faster to go through this whole equation manipulation process. Maybe it's not easier, but it is faster if you know what you're doing. So that's it for tonight's homework. Hope you all liked the video. Thanks for watching, and y'all have a great day.